All right, so let's do another example here on the worksheet. We want to analyze and sketch this graph. So there's the function there. So let's start with looking at the domain. Obviously with x squared minus 9, we're going to have, in the denominator, we're going to have all real numbers except x equals -3 and 3. We'll see how that plays in later. All right, intercepts. Okay. All right, x-intercepts. We would need the numerator x squared plus 1 to equal 0, but that's not going to happen for any real numbers, so there are none. Y-intercepts, we would set x equal to 0, and we get y equals -1/9, so that is the point 0, -1/9 is on the graph. All right, asymptotes. Okay, so as far as asymptotes, let's look for the vertical. And again, we'd be looking for places in the denominator that the denominator is 0 and the numerator is not, but that's what we're getting at x equals -3 and 3. All right, for horizontal, I have to take my limits. Remember, it's x squared plus 1 over x squared minus 9. It's x squared plus 1 over x squared minus 9. These are both your standard power over power as we go to infinity, and they're matching, so it's just going to be the coefficients. In both cases, it's 1 and 1. So we do have a horizontal asymptote at y equals 1. All right, so let's go now to extrema. We're going to need the first derivative. So again, the function we were looking at was x squared plus 1 over x squared minus 9. This is going to be quotient rule. So we're going to get 2x times x squared minus 9 minus x squared plus 1 times 2x all over x squared minus 9 squared. I'm going to skip some of the details here so I can get to the good stuff. So if you simplify that, you should get -20x over x squared minus 9 squared. All right, again, we'd be asking when is, that should be the first derivative equal to 0. When does the first derivative undefined when the original function was defined? Obviously, x equals 0 would make the first derivative 0. And there isn't any place where the first derivative is undefined that the original function was defined, because we already took out -3 and 3. All right, so if we go to our chart here, we're going to put the -3 and 3 discontinuities in. I like to label them so we remember what they are, why they're there. And we do have the 0. Okay, so if I start plugging in numbers, you should get, remember, it's really going to all depend on the -20x on top. So you're just going to get the opposite of what the sign of x is. The bottom's always positive. So we're going to have positive there, negative, and negative, telling us here f is increasing, f increasing, f decreasing, and f decreasing. Okay, so that would give us at 0, we're going to see that we have increasing, decreasing. So we actually have a relative max there at 0. Oh, we already figured that out before because that was our y-intercept at 0, -1/9. Okay, so on we go to the second derivative in search of inflection points. All right, so the second derivative is going to be quotient rule on that first derivative. And again, I'm going to skip some steps there and get to the end result. So you should get that it's 60 x squared plus 3 over x squared minus 9 cubed. Okay, so this would be from quotient rule on f prime. Okay. So again, now I check that the second derivative, where is it 0? Second derivative undefined, where the original function was defined. Oh, well, this numerator is never going to be 0, so there are no places where it's 0, and there are no places where it's undefined and the original function was defined. So the only thing that we are going to have on our second derivative chart are the discontinuities at -3 and 3. And if we go in here, now the numerator is always going to be positive, but we do have to look at the denominator when we're evaluating this, because that can change. So when you're at -4, you would get a positive result because you're getting the 16 minus 9 positive, cubed positive. But if you're at 0, say, you get a negative inside 0, you get minus 9, then cubed, that's still negative. And then if you're bigger than 3, you get positive, meaning you do get f concave up here, f concave down there, and f concave up there. But again, -3 and 3 are places where the concavity changes, but they're not points on the graph. They're discontinuities. So we can say that we have no inflection points. Now let's go to a sketch. Okay. So, what did we know? Well, we knew that we had a y-intercept of 0, -1/9. So I'm just going to place that down here. I don't need it to be super accurate. I just need to know, label it, say, 0, -1/9. All right, and we know that we had we had vertical asymptotes at 3 and -3, so let's call that 3, let's call that -3. Okay, we're not going for exactness here, we're going to see the details. Okay, and then we also had a horizontal asymptote at 1. I might need a little more room up here. Okay, so, all right, so what else did we have? Well, we saw a couple of things. We saw that this 0, -1/9 was a relative max, so it is going to be topping out there. All right, so what else? Well, there isn't a lot going on here. We do know what's happening to -3 and 3 because we found that it has to be concave down there. And these are asymptotes at -3 and 3. So I actually just have to end up going down there and asymptotic. All right, like that. All right, but what about on the other sides? Well, I have to be concave up, as it says, on both from both -3 back and 3 forward. And what did we find out before? That they were headed towards this horizontal asymptote of y equals 1. So they have to end up, so really, if I look at the right side here, it would either have to be heading there like this or heading there like that. But realize this one on the bottom here is concave down, so that's not going to work. All right, so let me get rid of that. It actually has to be this way, and it has to stay concave up, so it must just go up like that. And similarly on the other side, it has to be concave down and head towards that y equals 1, and then up like that. So here we get our graph of this function here, and it's very nice. We have the y equals 1 horizontal asymptote, we have the x equals 3 and x equals minus 3 vertical asymptotes, and we have this relative max at 0 and -1/9, which is also our y-intercept. So again, we got a very nice sketch of this function from all this information.